Hello, I'm Noel. I would like to talk to you about a new response model that is dedicated to the analysis of bounded data. And somewhat unusually, I would like to introduce this model from a psychological hypothesis. That's what we are interested in. Basically, the data I'm interested in are collected through web interfaces and through sliders on a screen. It's quite easy to collect such data on a web form, and people have just to slide the cursor and indicate their response that way. The hypothesis we'll make here is first based on the remark that people just have, with such response scales, just have two reference points to judge, to construct their response. And as such, we will assume that they will grant some latent value to both labels, to both extreme labels, and that they construct their response simply by calculating kind of weighted average between these two values. I mean that if you give arbitrary location of 0 and 1 to both extreme points, then people will locate their cursor just at the average of the values they granted to both extremities. That's the basic idea. So if we assume that those psychological values are non-negative quantities, then it's quite natural to assume that, for instance, those values follow or are drawn from a gamma distribution. Other choices are possible, but this choice is pretty convenient and lead to an interesting result that has been pointed out by Jay, that the ratio of those values will then follow a beta distribution. Now, this is kind of justification of the beta distribution as a response distribution. But we would like to connect this to structural parameters, I mean to subject and item parameters. I will come to that point later, but just to show you or to remind you of the different shapes that the beta can take, I would like to point the fact that it can take a bimodal shape for some parameter values, namely when both parameters, m and n, fall below 1. Now, we can construct a response model by assuming a beta distribution on each pair of subject and item. And if we do so, we need a double subscripting convention here, and if we do so, it is tempting to interpret the both distributional parameters as an acceptance and a refusal parameter respectively, because M will modulate the impact of X, the agreement response on the shape, and 1 minus X that might be interpreted as an implicit refusal of the item, then will be modulated by N. So I propose to interpret these two parameters as acceptance and refusal parameters, respectively. Now, we want to connect this hypothetical distribution to what could be called structural parameters, namely subject and item parameters. And one simple way to do so is to express M and N as, respectively, an increasing and a decreasing function of theta, if I call theta some kind of attitude parameters on some latent continuum. So the model is basically one-dimensional. If you put some constraint on the signs of the slopes, then you will get basically an increasing function for the acceptance and a decreasing function for the refusal. So giving sense to some latent continuum with an implicit increasing agreement. Here is a plot, like it is. And an interesting aspect of the thing is that in the middle range here, when both parameters fall below 1, then what you basically get is bimodal response density. Of course, a question is, does it make sense from a psychological point of view? And I will come to that later. Now, if you define a structure on the distributional parameters, then you can compute an expected rating function. The expectation in the beta is quite simple, and Jay has shown it, is just the ratio of the two parameters. So if I replace m and n by their expression here, then what you basically get is a logistic expected rating curve, which is quite familiar, which may have kind of rash flavor, something. Now, putting things together, here you have everything of the model. First, the acceptance and refusal functions, and second, on the right plot, what you have is the expected rating curve, which have this logistic shape, and then a contour plot or a density plot of all the shape that the beta can take for all theta values on the x-axis. So as you can see, in the middle range, between -2 and 1 for these parameter values, what you get is very high response densities at the boundaries of the scale, of the response scale. What this basically means is that for a fixed theta, that is, for a fixed attitude level, you can get basically two extreme and opposite responses equally likely. This is quite counterintuitive, but the question is, let us see if on some data it can be meaningful. Of course, if your acceptance and refusal parameters stay above 1, then no bimodality would appear, as is the case here, where delta 1 and delta 2 are simply equal. And what you get in the middle is the uniform distribution, the beta 1, 1. And if both parameters are above 1, then you're sure that the beta is always unimodal. Now, I will apply this model to response to a process of change questionnaire in a smoking cessation study. We have some background here about processes and stages of change provided by Prochaska and De Clemente's work. And what we know about smoking cessation is that it can be described as stages, discrete stages, which are here defined. And some interesting features are known about transition probabilities, but it's not quite necessary to go into the details here. What we will do is simply to analyze responses to 20 items that we design, items including cognitive items and behavioral items. Cognitive items refer to information taking, emotion, and so on, and behavioral items has to do with what you do concretely to not smoke. Cognitive processes are known to be predominant in the first stages of change and behavioral in the last two stages of change. Here is the result. After estimating the parameters of the beta model, what you get is a scaling of the items, and you can note that most of the cognitive items are on the left part of the continuum, and most of the behavioral items are on the right-hand part of the continuum. Interestingly enough, you can note a correspondence, a quite close correspondence between the attitude values. Here, the attitude can be interpreted as a kind of readiness to change score. You have a correspondence between these scores and the previously defined stages of change. You can see that lower scores correspond to first stage and higher score to last stages. So that's interesting to note that we have this correspondence. Now examining some sample items in the real data. Here you have what happened to the I think of the fact that many people quit smoking item. And as you can see, the slopes of refusal and acceptance might be quite different. And also, both of them may fall below 1, so that really bimodality occur in some middle range area. It's a cognitive item, and you have another example here of a behavioral item. I avoid taking cigarettes with me. Not all items display the bimodal pattern. Some of them are quite usual, I mean unimodal, and, but about half of them display this pattern. So, in conclusion, I will say that an extreme response style, by which I mean the possibility that the very same person could provide extreme responses, here might be related to the content in itself. And a given true attitude may lead to two opposite manifest responses, which is counterintuitive, but this data seems to lend some support for that idea. And then a challenge might be to design some kind of item fit statistics, because here, as soon as you have bimodality, it becomes clear that central measures, such as chi-square derived measures, are probably not appropriate. I thank you for your attention. Any question? Yeah?
In your abstract, you mentioned that you're going to end with parallel cusp models of change. Are you going to say, can you say something about
About what? Excuse me.
about cusp models of change, the catastrophe models of change of this type of process?
Cusp?
Cusp.
Oh, yes.
Yeah.
Look at this. In cusp model, which are not defined in psychometrics as far as I know, it's just a metaphoric model, but you could think of a cusp model just as taking an S shape, but in the mathematical definition of a cusp model, the middle layer of this S is defined as non-reachable. So probably a cusp model is not very useful if you want to use it as a response model, just because the central layer is not reachable. Probably a bimodal response model here is more appropriate or more useful and more easily interpretable in terms of psychological concepts. So if I had to make a parallel between both, and indeed it's tempting, I would say that probably we don't need to draw some kind of multi-valued function, because this is implied by cusp model. We don't need to invoke such weird functions. Just a bimodal hypothesis is interesting, noting that the expected rating curve here remains perfectly simple and increasing and easy to interpret. I'm not sure I fully replied to your question, but okay. Any other question? Okay. Looks like we are done. Thanks a lot.